Hey there, Nick here. In this video, we're going to go over a shell scripting pattern called cd or exit, and I do have a demo script here all set up and ready to go, but take a wild guess here what you think is going to happen if we run the script. So we're going to try to cd into a path that doesn't exist, and then maybe print something out. And chances are, you already guessed here, if you run the script, we are actually going to get this print message here, and this path doesn't exist. And this lies the problem here. So, imagine that you have a shell script where you're seeding into a path where you expect it to exist, and then you just run a whole bunch of other stuff. Some of those things could be RMFing basically every file in a directory, or maybe creating a whole bunch of files, or doing something with files that you expect to exist here, but could potentially exist in other locations. So, this could be a scenario where you accidentally delete a whole bunch of files by accident, and that's not good at all. Now, I know you're probably thinking like, well, just use sed there, and then you can rerun the script and everything is good to go, because as soon as the cd command encounters an error here, then the script is going to exit. We can see here with an exit code of something that's not 0, and we are good to go. The rest of the script will halt, and that's exactly what we want. But it's pretty interesting, when it comes to something as dangerous as maybe moving files or creating files or deleting files, and you expect those things to happen after seeding into a script. I kind of like treating this like security, where, just having multiple layers is really beneficial. So there is this pattern here where you can do cd into whatever path that you want, or exit. And even if we don't have set e defined here and we rerun the script here, we will see that the script will halt here because it's going to try to cd into a path that doesn't exist, and then it's going to fail. So then the or condition here is going to happen where we're just going to exit out. And you can even use this in combination with set e as well. You're not going to get like extra protection here, but you will at least, get the benefits of set e there. But still, even using set e, I do like having both of these here, because sometimes in a script, it is beneficial to turn set e off. You can basically do plus e instead, just to work around some cases where that you're going to have an error, handle them in the way that you want. Maybe you forget to accidentally use set E again. So, just doing something like this is pretty helpful. And what's kind of neat too is if you are using ShellCheck, which I've done videos about in the past, I'll leave links to those in a card potentially. But if you run ShellCheck on this, ShellCheck is going to think like, okay, that's no problem. Everything is all good. Now, if we remove the set E here, we can also rerun ShellCheck here. Again, all good because we're using or exit there. However, if we just leave it like this and we run ShellCheck, then it's going to be like, you know what? You should probably do cd or exit in this case here. And then it links us to SC2164 here, which is, the actual validation or linting error here that we get here. And it says like here, here's some problematic code. Like imagine seeding into a directory and you just try to like remove some stuff. And the correct code here is like maybe cd into the directory and then use or exit. And that's going to make sure that we don't accidentally delete things or etc. But what's really cool about ShellCheck is, they don't just say these rules and then just leave you with that. They also go into like the rationale, like why you might want to do this, right? And a really good use case here is maybe you just accidentally misspell a path, or, in this case, directory doesn't exist, etc. And they just go over some conditions here of, when this might actually happen. This could be really bad if we're really messy here, if it involves creating or deleting a whole bunch of files here. And yeah, so it also goes to say, if you're using set E, then you're protected against that. But I still do think it's a good idea to double up here and just add both. And yeah, this recently came up for me, not in a case where like I accidentally deleted a whole bunch of stuff, but I was just doing a little bit of maintenance in my .files repo, which I'll link to in the description. And, I wanted to make my alias file a little bit more POSIX compliant. And I ran ShellCheck against my aliases file, which is something I haven't done before. And it pointed this out on here because if I actually, no, I don't want to kill that window. If I go to my aliases file here, this actually doesn't have a shebang or set E on here, because you don't really need to do that inside of an aliases file. Instead, like, this file is expected to be sourced in a different file here. And if I go down to, I think it's one of these, somewhere I'm like seeding into a path here. Yeah, and I didn't have these or exits here. And ShellCheck was like, by the way, probably would be a good idea to do that. So I listened to ShellCheck and I put it in here. And in this case, set E really is happening from the script that's calling the script. But yeah, still, anyways, a good idea to have that. But that's about it for this video. Let me know in the comments below if you're going to be using this pattern. Maybe you can make a case for not wanting to do that, even if you are using set E. So let us know below. That said, if you liked the video, please give it a thumbs up because it really does help a lot. Thanks a lot for watching, and I will see you in the next video.